Hi, this is Mr. Adams from Midwood High School, and we're looking at the topic of stoichiometry. And classically, stoichiometry has a Greek root to it, and the definition has been termed counting of atoms. Now, normally when we talk about stoichiometry, math is involved, and automatically a lot of panicking ensues. So we're going to try and get rid of that panicking. In stoichiometry, folks, the term mole will come up, and when we're dealing with the mole, it's very flexible because we can go from the mole to mass in grams, and anytime we go from mass in grams to mole or mole to mass in grams, either direction, we need to use something called the GFM. Alrighty? We can also go from the mole to number of particles, or we can go from number of particles to the mole. And anytime we go from number of particles to the mole or back and forth, we need to use Avogadro's number. Likewise, if we go from volume of gas to the mole, or from the mole to volume of gas, we need to use this number right here, 22.4 liters of gas at STP. Now, ladies and gentlemen, there's been some controversy in class. For example, people would say, well, how come the mole, the GFM of anything is equal to 1 mole? And the analogy that I use is this. If we have a dozen elephants and we have a dozen mice, okay, do we have the same number of them? Yes, we do. We have 12 of each animal, right? But are the masses of the animals the same? For example, do 12 elephants weigh the same as 12 mice? No, so the masses will not be the same. Okay? So, likewise, in the different elements, if you have the same number of elements, okay, if you have this number of elements, 6.02 times 10 to the 23rd power of elements, you have 1 mole of elements, okay? Now, if the elements are different, for example, you have carbon, you have phosphorus, you have different elements, the masses will be the same, okay? The mass will be different, the mass will be different, but the number of them would be the same. I'm confusing myself. Okay, so we're moving on. GFM calculation. Now, GFM calculation is simple, guys, but the only thing we have to watch out for is our parentheses, our subscripts, and if you're given a name, getting the correct formula. Now, if you forgot how to do formula writing or you're a little bit shaky on it, no problem. Just go to the videos on formula writing and naming, and review those, okay? But GFM simply means gram formula mass, okay? Gram G, formula F, M mass, or as I like to say it, the mass of the formula in grams. So, for example, if you had to calculate the GFM of CH4 methane, you simply determine how many carbons do you have, and that's 1. You determine the mass of carbon. You look on your reference table, so have your reference table out as always. You put 12.0 right there. Okay, so 1 times 12.0, that's carbon. You take into consideration the hydrogens. You have 4 hydrogens. Now, I use to 1 decimal place, but some folks use to 2 and whatever, but use whatever your teacher tells you to use, so I'm using to 1 decimal place. So 1 times 12 gives me 12.0, and 4 times 1 gives me 4.0, okay? So I'm going to add those up, and that's going to give me 16. So 16.0 grams per mole, okay? Grams per mole, that's going to be my gram formula mass of methane CH4. Now, on the other hand, I have another compound right here, BaClO3. Okay? Now, we're going to find the GFM of this guy. We're not going to panic. We'll simply put the Ba down, Ba, okay? We determine that we have 1 of them, and we look at our reference table, and this mass is approximately 137.3. Okay? Now we have ClO3 here, folks. We have two chlorines. Now we have to be careful. If you have parentheses and a subscript on the outside, that subscript distributes to the whole of what's inside of the parentheses. So we have chlorines. We have two of them, and we're going to use 35.5 for each chlorine. Okay, and for oxygens, how many do we have? Yes, we have 6 oxygens, okay, at 16.0 each. All right, so we're going to add those up. We have 137.3. We have 2 times 35.5. That's approximately 71, if I'm not mistaken. And 6 times 16, that should be around 96. Okay? And as always, we have our calculators with us, because in stoichiometry we need our calculators. We're going to add those guys up. Okay, so I'm going to do that right now. You do that with me. Okay, so we have 137.3 plus 71 plus 96. Okay. And I'm getting 7.3 plus 71 plus 96. Enter. 304.3. A bit of technical difficulty there. 304.3. Okay. And that's going to be grams per mole. That's good. That's my unit. All right. So that's GFM in a nutshell, guys. Once again, you can be given names. You don't panic. If it's ionic, you do the crisscross method. You get the formula. And if it's covalent, it will have Greek prefixes in it. You go from there. You write it down as needed for your Greek prefixes. All right, moving on. Now, you can be asked to do simple mole to mass conversions, folks. And I have an example here. How many grams are in 2.4 moles of CH4? Okay, now these funny parentheses I have here, guys, represents our conversion factor. Okay, so I'm going to put a line right here to represent our numerator and our denominator. Now, simply, guys, what we're given 2.4 moles. Okay, so what we're going to do, we will put that on the outside. 2.4 moles of CH4 on the outside. Now, ladies and gentlemen, whatever item, whatever unit you're looking for goes always in the numerator, goes on top of the conversion factor. So in this problem, we are looking for grams, so we will put grams of CH4 in the top. All right? Now, we are looking to cancel moles, guys. So what do? We put moles, that same unit, moles of CH4 in the bottom. So what eventually is going to happen is the moles will cancel. We'll be left with grams. Now, before we can do the actual calculation, we need numbers to go here and here. Now, ladies and gentlemen, we'll go back for a second. All right, to this first slide right here. And in this crude diagram, we see that anytime we want to go from moles to mass or mass to moles, we need to use the GFM. So we need the GFM of CH4. And the GFM of CH4 we conveniently calculated over here, which is 16 grams per mole. Okay? So, what's going to go in the top, guys, is 16.0 grams. That's the GFM of CH4. And the GFM of any substance is always equal to how many moles? Okay? 1 mole. All right? Because we did it in class already. 1 mole. So 1 mole goes in the bottom. Now what happens next is simple. The mole CH4 cancels. Okay? Now back to my calculator. Hope it doesn't betray me this time. We are going to multiply 2.4 times 16.0. Enter. Okay, that should give you approximately 38.4 grams of CH4. Okay? And that's it. Very simple. Okay, so once again, this is using one conversion factor. The item you're looking for always is in the top. The item that you want to cancel, okay, will be here on the outside and here on the bottom, and you're good to go from there. All right, so we're moving on. Now, we're doing mixed conversions. We did mixed conversions. We started yesterday. We continue today. And there's a bit of controversy with it. People are a little flustered. But we're not going to panic. We're going to go a bit more slowly with it. This is a typical problem right here. How many molecules are in 120 grams of SO2? Now, SO2's name is, yes, sulfur dioxide. Okay, so we're going to map it out. We are given grams to start out with, so we have our grams right here. Now, we made the analogy in class. If unsure or concerned, simply go through Penn Station. Think of the mole as Penn Station, folks. Okay, because once again, we can use the mole, okay, to go to any of these different places. We can go from moles to particles, we can go from moles to grams, we can go from moles to volume. If we start at grams and we change it to moles, okay, we change to moles, we can go to any of the other guys. We can go to particles, we can go to volume from there. Okay, so we're not going to panic. So we'll do one thing at a time. All right, so we're going to change to gram. We have grams. We're going to change to moles. Okay, in order to change something from grams to moles, we need the G word. Yes, we need the GFM. Okay, that's one step. Now, we want to go from moles to number of particles. Now, number of particles could be ions, it could be molecules, it could be anything, apples, oranges, whatever. But as long as we're talking about number of particles in the mole, we need Avogadro's number, which is what? Which is 6.02 times 10 to the 23rd power. So this is a brief map of what we're going to do. All right? And we already know how to go from grams to moles. Okay? But what's new to us is setting up another conversion factor to take us to that extra step. All right, so look, on our next slide, we have the same problem. How many molecules are in 120 grams of SO2? We put the 120 grams, okay, of SO2 on the outside. Okay, we're going to set up a conversion factor, so we put our line here. Now, what do you think is going to happen? We want to cancel out grams of SO2, right? So what do you think we put in the bottom? Yes, we put grams of SO2 in the bottom. Good, so the grams SO2, grams SO2 will eventually cancel. Now, we're going through Penn Station. Penn Station for us is the mole. Okay, so what we're going to do is ask ourselves, what's the relationship between grams and moles? Okay, it's the GFM of any substance is always equivalent to 1 mole of that substance. So in this case, it'll be 1 mole of SO2. Okay, so let's take a breath. What are we doing again? We are trying to change grams of stuff to molecules of stuff. Okay? But before we jump from grams straight to molecules, what we're going to do, we're going to make life simple. We're going to change our grams, okay, our grams into moles. All right, so we need the GFM of SO2, so we can calculate that right here. We have S, we have one of them, and the mass of S is, I think, 32. We have oxygen, we have 2 of them, and the mass of each of those guys is 16.0. Okay, so we have 32, and 32 again. And 32 and 32, no calculators, is 64. Okay, so we got 64.0 right there. All right. Now, ladies and gentlemen, what's going to happen is our grams and our grams will cancel out. So we're not doing any calculation yet. We're just setting it up. All right. So now we're left with moles of SO2 here. We want to change moles of SO2 to molecules of SO2. All right? So we set up our other conversion factor. We're not panicking. We have moles of SO2 right here. If I want to get rid of moles of SO2, how do I do that? Yes, I put moles, okay, SO2 in the bottom. That's going to help me get rid of moles SO2 in the top. All right. Now, since molecules is a type of number of particles, okay, we need whose number? Yes, we need Avogadro's number. Okay, so we need 6.02 times 10 to the 23rd molecules of SO2. Alrighty? Okay. Now, Avogadro's number is always equivalent to how many moles of stuff? Yes, 1 mole of stuff. So what's going to happen now, people, is this. Our moles SO2 will cancel out now. Alright, so what are we left with? We are left with molecules. What the problem stated that we are to find, we stop. Now we have to do a simple calculation. So I'm going to go ahead and do that. You pause the video and do that also. We'll see if we get the same answer. Okay. Now we got 6.02 exponent 23 times 120 divided by 64. Okay, and my calculator is giving me 1.13 approximately times 10 to the 24th power. Okay, and that will be molecules of SO2. Alrighty, so that's my answer. So check and see if you got the same answer. Okay, moving on. Now once again, folks, you think of the mole as Penn Station. If you're going from volume of stuff and you want to get to number of particles, you simply change this to moles first, then you change it to particles next. Now what do you need to change to number of things? You need Avogadro's number right here. If you're dealing with volume, you need this number right here, 22.4 liters. Okay, and so on. If you're dealing with mass of stuff, you need the molar mass, also known as the GFM. Okay, so you can go anywhere. You can go from this guy to this guy. You can go from this guy to this guy, this guy to this guy. Okay, it's very, very flexible. Alrighty? Okay, and moving on. Now, pause the video. I want you guys to do this problem right here. Okay, and we'll see what we get, and we'll wrap it up. Okay, you're starting with 10.2 liters, 10.2 liters, all right, of CO2, CO2. So we got 10.2 liters of CO2. We want to change that to grams. So what we're going to do simply, guys, we're going to change our liters into moles first, and then go from moles to grams. Okay, so we're going from liters to moles. Okay, moles Penn Station. And then we're going to change that from moles into grams. Alright, that's our map. So we're going to put our line here to separate the numerator and denominator. If we want to get rid of liters of CO2, we need the watts. We need the same units in the bottom, liters of CO2 in the bottom. Okay, so this top and the bottom will eventually cancel. Now, we're changing it to moles, so we need moles of CO2 in the top right here. Okay? And we take a breath. We have liters in the bottom, the liters will cancel, and we have moles in the top. Now, we said before, people, that if we're dealing with volume of gas at STP, we need to use that number right there. It's kind of small right there, that 22.4 liters. Okay, so that's what we're going to use in the bottom here, 22.4 liters. Okay, now 22.4 liters of gas at STP, okay, standard temperature and pressure, is always equivalent to 1 mole. All right, so what's going to happen now? Our liters of CO2 will cancel out, and we'll be left with moles over here. But the question asked us to find how many grams, so we're not going to panic. We went from our liters to our moles. Let's have the problem done. We have to now go from moles to grams. Okay, so all we do, we put another dividing line. Okay, and we say to ourselves, we want to get rid of moles of CO2 up there, so we put moles of CO2 in the bottom. We are looking for grams of CO2, so we put that in the top. Okay, we don't have to put any more conversion factors because we have the item, the unit we're looking for here. All right, what's the relationship between moles and grams? 1 mole of any substance is equal to the G word. Yes, the GFM of CO2. Now we know carbon, okay, is 12. And we know oxygen, we got 2 of them, is 16. Now 2 times 16 is 32. And 32 plus 12 is 44. Good. So 44 grams goes there. 44 grams of GFM of CO2. The moles of CO2 cancel. Now what we're going to do now is just simply multiply across and divide. Okay, it doesn't matter if you divide first or whatever, but I like to multiply first. So 10.2 times 44. Okay, you can pause the video and do that. We'll see if we get the same answer. Okay, 10.2 times 44. Okay, divided by 22.4. Enter. Okay, I got 20.035, so I'm going to call that for short 20.04. Okay, I'm going to call that 20.04 grams CO2 for simplicity. And that's it, folks. You can use the mole map that's here, or the one I drew in front, so the one we have in class already, to calculate any variety of conversions, folks. Don't panic. People wonder when did I use what, and when do I have to use it, or whatever. The question will tell you when to use it. Follow the question carefully. Use only what you need, and don't put everything, all these guys in. Use only what you need. And as always, hard work plus sacrifice equals success. I hope this video was a help. Our next quiz will be on GFM calculations right here. GFM calculations are simple, but please review formula writing in the other videos. And as always, studying beats anything else, and practice. So take care. Thank you.